Hi everyone. In the previous videos we discussed about motion, its types, uniform and non-uniform, and we also came across physical quantities like distance traveled and displacement. We even saw a few problems about them. We already have studied about speed, which is also called as rate of distance traveled, and average speed can be identified by the formula total distance traveled divided by total time taken. In today's class, we will discuss about a new concept, speed with direction. It's called as velocity. Now, what happens is, to understand the rate of motion of an object in a better way, we have to specify its direction as well as its speed, means the magnitude. In earlier class, when we discussed speed, we talked about only its value or magnitude. Whereas velocity, when you discuss, we will have to talk about two things, the magnitude or the speed itself, as well as in which direction it takes place. So this new quantity which specifies both these aspects, that is the speed as well as its direction, is called velocity. Its SI unit is same as the SI unit of speed, meter per second. There are other units also we have come across. For practical reasons, we will also consider kilometer per hour and centimeter per second, but here we will use for our problems meter per second only. So look at these images. We see the readings are same on all the four cases, that is 120 kilometer per hour, but the velocity in each case is not same. Why? Because the directions are different in each case, because of which we say that the speed is same in all the four cases, but the velocity is different in all the four. Velocity is the speed of an object moving in a definite direction, or you can also say velocity is the rate of displacement. That is also, rate means the displacement divided by time. In physics, whenever we discuss about any quantity divided by time, we replace it with the word rate. In regular life, whenever we buy things, we talk about rate of an object, that is with respect to its cost or money. Here, the rate is always specified with respect to time. So any quantity divided by time will be called as rate of that quantity. When I divide displacement by time, we call it rate of displacement. So we can say speed is equal to distance traveled by time taken, but which means it has only one thing, that is value or magnitude, whereas velocity is speed with direction. So just have a look at these connections here. I'll highlight. So we say speed is equal to distance traveled by time taken. What is velocity? It is speed with the direction, means distance traveled with the direction divided by time taken. Distance traveled by with the distance is nothing but displacement. So we can say velocity is equal to displacement by time. See the difference between speed being distance traveled by time taken and velocity being displacement by time taken, which can also be read as rate of displacement. So velocity and speed both have the same SI units, but velocity has direction and magnitude, both speed has only magnitude. We will discuss about such type of physical quantities in a different video. Velocity undergoes changes under three conditions. Let us have a look at that. First is changing the object's speed. That is, in this case, example, a ball is moving. A player comes and kicks the ball in the same direction. So the direction of the object does not change, but its magnitude or value changes. So we say the speed changed here, then automatically velocity also changes, because velocity depends on two things, speed as well as the direction. The second case is changing of the direction also changes the velocity. Here an example, a biker without changing the speed of the bike turns the bike in a different direction. in this case, what happens is, since the direction changes, we say velocity changed, though speed has not changed. So velocity, till now we have understood that it changes in two cases. One is changing the speed of the object or changing the direction in which it is moving. And third case is when both of them change, the speed as well as direction. Example, imagine a cricket batsman waiting for the ball. The ball comes at him about 90 km/h speed. Then he hits it in a different direction so that the ball goes away, maybe probably at 120 km/h. Now both speed as well as the direction both change. In this case also we say velocity has changed. So velocity is said to have changed under three conditions. One, when the object's speed or only the value changes. Second one, there is no change in speed but only the direction. Then also we say velocity change. Third and the final one, if both of them change, the speed as well as the direction, then also we say velocity has changed. Now then we talk about a new quantity called average velocity. This concept is useful because of all objects do not always move in uniform motion. Some of the objects move in uniform motion while others in a variable motion or non-uniform motion. When an object is moving in a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. Means, imagine a jogger in a park. The person changes his gait or speed according to the crowd. Suppose there is a patch of stones there, the runner automatically slows down. Then he finds a nice grassy patch where he can run very freely. So his velocity changes, and probably he will take some turns here and there. So velocity again changes. So in this changing velocity, if you have to calculate the total average velocity of the object moving, in that case we will use a formula. The formula goes like this. Average velocity is equal to initial velocity plus final velocity divided by 2. That is, we will be taking the arithmetic mean of the initial velocity and final velocity. The formula mathematically can be showed as V average is equal to U plus V upon 2. Here VAVG is nothing but average velocity. U is initial velocity, V is final velocity. Now let us see an example where in a problem we can apply the formula. The initial velocity of a body is 30 meter per second and final velocity is 60 meter per second. Calculate its average velocity. Let's go for the solution. First let us write the given data, that is initial velocity. We'll call it as U, which is equal to 30 meter per second. Final velocity, we'll call it V, which is equal to 60 meter per second. We know the formula for average velocity is equal to U plus V by 2. Substituting the values, V average is equal to 30 plus 60. Here U is 30, V is 60. So 30 plus 60 upon 2. On adding 30 plus 60, we get 90. 90 upon 2, which is equal to 45 meter per second. You should always remember to write the units properly at the end of the answer. Otherwise, it will not be considered as a valid answer. Second example. Usha swims in a 90 meter length pool. She covers 180 meters in 1 minute by swimming from one end to the other end back along the same straight path. Find the average speed and average velocity of Usha. Let us try to understand the question. So let us take a diagram here. There is a person called Usha who swims along the swimming pool of length 90 meters. So while Usha goes to one direction, she has covered 90 meters. Then she turns around and then covers again 90 meters backwards. To complete this whole process, she takes 1 minute. Means if she has taken equal time on both directions, we can consider 30 seconds on one direction and 30 seconds in the opposite direction. Considering this, let us try to solve the problem. Let us have a look at its solution. So what are the things given? The data is distance covered by Usha in one direction, that is initial distance covered is S1, which is 90 meters, the length of the pool. So again, distance covered by Usha in the opposite direction, let us call it S2, the final distance, that is 90 meters. Then time taken by Usha in the first direction, let us assume it is 30 seconds, and time taken by Usha in the opposite direction is also 30 seconds, that is T2. See, please try to understand that total time taken to go and come is given as 60 seconds. Even if we don't consider T1 and T2 separately, total time can be taken as 60 seconds or 1 minute. Why we write it as seconds is because we need all the solutions in SI units, and we know that the SI unit for distance is meter and for time is seconds, and for finding out speed and velocity should be in meter per second. So the time given by them in the problem is 1 minute. We will convert it into seconds. So the total time to go and come back is 60 seconds. So displacement. What is displacement? It is the shortest distance between initial point and final point. When Usha started from one end of the pool and came back to the same place, so the initial point and the final point both are same. So the distance between the initial point and final point becomes 0 because she has come back to the original position. Now let us see what is the total time taken. Total time taken is the initial time taken to go in one direction, and T2 being the time taken for the opposite direction. Even if they are not equal, the total time is 60 seconds. So let us see how to apply the formula. Formula of average speed. First part they have asked is speed. So average speed is total distance travelled by total time taken. We have covered this type of problems in previous videos. We could refer to those videos also. So we can call summation of all the distances, that is 90 plus 90. S1 plus S2 becomes 90 plus 90, which is 180. And total time taken will be 60. So in the denominator we have 60 seconds, which is 1 minute what they have given. So the final answer will be 180 divided by 60, which is 3 meter per second. 0, 0 cancel, 6 ones are 6 threes are 18. So what is the average speed? That is 3 meter per second. Let us talk about average velocity. Average velocity is given by, there are two types of formulae. One you have seen, it is u plus v by 2. Yes. And the other option, from the definition we know that it is rate of displacement. What is the rate of displacement? Displacement divided by time taken. So what is the displacement? The displacement from the above data we know it is 0. So 0 divided by time taken, which is 60 seconds. 0 divided by anything is 0. So the final answer will be 0 meter per second. So the average velocity is 0 meter per second. What we identify here is the average speed and average velocity need not be the same always. They can be different. Thank you.